Today I am explaining properties of triangles. Before going to that one, introduction of the properties of triangles. Already some properties you know, everyone. That is the properties of in school level. Sum of three angles of a triangle is 180 degrees. That is one of the property. And sum of any two sides greater than third side. Second property. Third one is difference of any two sides less than third side. Now I am explaining related to trigonometry. Some more properties. Now, properties of triangles, or you can call it POT. Before going to that one, now in triangle ABC, the length of side BC, this is opposite to A, so this length you can take as small a. Opposite to B, this length you can take as small b. Opposite to C, this length you can take as small c. Sum of these three sides lengths you can call as perimeter, denoted by 2s, small s, that is a plus b plus c, or you can write as small s is equal to a plus b plus c by 2. This even you can call as semi-perimeter, that you can call as perimeter. Area of triangle denoted by delta, that is area of triangle ABC is denoted by delta, that is area of triangle. Now related to circles, now the circle passing three vertices of a triangle ABC, that you can call it circumcircle. The circle passing through the three vertices of a triangle, that you can call as circumcircle. Now you can take any two sides. I am taking side BC and side CA. Draw perpendicular bisector of BC. Bisector means it is bisects and perpendicularly. That line you can call as perpendicular bisector. Now you can take one more. This I am taking this side. One more perpendicular bisector. This one more perpendicular bisector. It is perpendicular and it is bisect. Means these two lengths are this. Then this point you can take as D. This point you can take E. Point of intersection of two perpendicular bisectors. Suppose you can take one more also. The point of concurrence, that you can call it point of concurrence of three perpendicular bisectors. Now it is the two now. The point of intersection of two perpendicular bisectors you can call it circumcenter, denoted by capital S. Small s semi-perimeter. Capital S is circumcenter. Now it is the center. Now S is center, A is the radius from Sine. S is center from A to S to A, that length you can take as circumradius, either A or S to B or S to C. Length is always same only. Now that length you can take as radius. That length you can take radius. Now from S to A, radius is the center is there. Draw a circle. That circle passes the three vertices of a triangle ABC. Now this circle you can call as circumcircle. S is circumcenter, R is circumradius. That is SA is equal to SB is equal to SC is equal to R circumradius. This is also most important. And one more point. For using this one, angle in semicircle, that is 90 degrees. Angles in the same segment are also equal. That property is also using in the problems. Now, see here, one of the most important rules, that is sine rule. It is using in Olympiad exams also in the school level. Now, either RMO or IAPT and ASRA exams also. Now, it is given every time. It is given by using this formula. Some problems it is easily find out. Now, in a triangle ABC, now I am finding sine rule. Sine rule. Now, in a triangle ABC, draw from vertex A to draw perpendicular to the opposite side. Draw perpendicular to the opposite side. The vertex is D. Now, this is angle B, angle C. Now, sine B is equal to, from this one is, already this length is small a, this length is small b, this length is small c. Now sine b is equal to, this is 90 degrees now, AD perpendicular BC. Sine B, opposite side AD by hypotenuse AB. That is, AD length you don't know. AB length is what? B is small c, cross multiplication. AD is equal to small c into sine B. Now, AD is equal to small c into sine B. From this one again, this side you can take as sine C. Sine C. Opposite side AD. AD by hypotenuse, that is AC. But AC length is B. By the cross multiplication, AD is equal to small b into sine C. Observe this two. This is the length of AD only. This is also length of AD only. Can I equate this two? No, I am equating this two. From 1 and 2. From 1 and 2. Now, in place of AD, I am writing this one. B sine C is equal to C sine B. Now, sine B is in this side. B sine B by sine C is in the side. C sine C. Two ratios are equal. B by sine B is equal to C by sine C. Similarly, in the same way. Otherwise, I am writing here. Now, I am writing here. Now, send this side B by sine B is equal to send this side C. C by sine C. This one take as equation 1. Otherwise, equation 3. Already 1 and 2 is over now. Equation 3. Again, from draw perpendicular from B to opposite side. That is P. Already I am writing here. B perpendicular to AC. Again, I am taking here this triangle. In this triangle, sine C is equal to opposite side BE by hypotenuse. This one hypotenuse. This is small e. From this one is BE is equal to small a into sine C. Small. Now again this side ABE triangle I am taking now. ABE triangle. In this triangle also sine A I am taking. Sine A is equal to opposite side BE by hypotenuse. This is right angle. Opposite side is this one. That is C. By using this one, BE is equal to C into sine A. Small c into sine A. Again, this can I equate this to? This also BE value. This also BE value only. Can I equate this down? From this one is here A sine C is equal to B, but B is equal to C into sine A. Sine A is in this side. A by sine A is equal to C by sine C. This is fourth equation. From third equation and fourth equation, A by sine is equal to from equation 3 and equation 4. From equation 3 and equation 4, A by sine A is equal to C na. C by sine C, but C by sine C is equal to what? B by sine B. From the equation 3, B by sine B, but B by sine is equal to C by sine C. This is statement of sine rule. See, most important. This ratio is equal to some constant. That constant value you got it. Length of diameter of a circle, circumcircle. That is 2r. Why is the circumradius? Otherwise, you can take as k also. Otherwise, you can take as k also. By using this one, this value actually got constant value. That constant value is equal to how much you got the value? Twice the radius of the circumcircle. That's why you can take as 2r. Now, by using this one, now I'm writing this side. Now I'm this one. Now, see small a by note point. Small a is equal to this to first one and last one 2r. A by sine A is equal to this 2r. A is equal to by cross multiplication 2r sine A. Similarly, second one and last one equating this one. B is equal to 2r sine B. C is equal to 2r sine C. This one. And if you want sine A from this one, sine A is equal to A by 2r. Sine A is equal to A by 2r. Sine B is equal to B by 2r. Similarly, sin C is equal to small c by 2r. If you want this ratio of the sides, you want means now ratio of the sides. Small a is to small b is to small c1 means small a, that is 2r sin a. Previously I explained na 2r and each unit of 2r with cancels. Remaining part is sin a is to sin b is to sin c. This is the ratio of sides. Sides angles ratio is equal to sides ratios. And one more concept, that is area of triangle. Area of triangle. Area of triangle. Now, area of triangle. Triangle ABC. Another one formula now. Area of triangle is equal to triangle ABC. That is, you can call it delta also. Half into base into height. Half into base into height. And one more formula is the square root of s into s minus a into s minus b into s minus. That also I am proving now. Now, from this one is, in this triangle, this is altitude, means height only. This you can take as base. Area of triangle delta is equal to half into base is BC, the height is AD. Now, the length of BC is small a. AD length, if you want, means you can apply sine rule. Sine A is equal to sine AB is equal to AD opposite side. This one you want AD. AD by this hypotenuse small c. AD by small c. AD is equal to C into sin. Substitute now. Small c into sin B. Now I am taking, this is the altitude. Suppose you can take this triangle I am taking. Now here sin c is equal to opposite side AD by hypotenuse B. AD is equal to here also B into sin c. Otherwise, you can, this is one formula. Otherwise, half into small a into AD I am writing as B into sin c. This is one more formula. Suppose you can take this as the altitude. You got one more formula, that is similarly got it BC into sin. That is one more formula. Area of triangle. Area of triangle. Half into AC into sin B. If you know two sides and include angle, if you know, applying this area of triangle formula. Half into AB into sin C, half into BC into sin A. From this one is, see, delta is equal to half into AB, BC sin A, BC into sin A, already I am finding previously by using sine rule, A by 2R. Sin A formula, A by 2R. Substituting now, ABC by 2 to the 4R. This is one more formula, area of triangle. And here also I am finding again small a 2R sin A, small b 2R sin B, small c 2R sin C by 4R. 2 1 ja 2 2 ja. Next 2. 1 R get cancelled. Remaining R into 2R, 2R square. Sin A into sin B into sin C. This is one more area of triangle. If you know three angles and circumference, if you know, applying this formula. If you know three sides and circumference, you know, applying this formula. If you know include angle on two sides, if it is been applying this formula. Otherwise, applying Aaron's formula also. I will explain later that one. Now, if you know base and side is, base and height is going to apply this formula. Next, and one more important point. One more property. Cosine rule. Cosine rule. Cosine rule. In a triangle ABC, here also I am taking cosine rule. In a triangle ABC, ABC, AD is perpendicular BC, AD is perpendicular BC. Now this is perpendicular. AD perpendicular BC. Now in this right angle triangle, ABD right angle triangle, in this triangle, by using Pythagoras, AB square is equal to AB square is hypotenuse one, sum of squares of other two sides, that is AD square plus BD square. AD square plus BD I am writing as BC, remove this part, BC minus DC whole square. Understood everyone? In place of BD, this part I am writing as total part, remove this part, BC minus DC. Now A minus B whole square formula, AD square plus BC square plus DC square minus 2BC into BC. Now this is also one more right angle triangle. From this right angle triangle, AC square is equal to AD square plus DC square. AC square plus DC square is equal to AC square is equal to AD square plus DC square is equal to AC square. AD square plus DC square is equal to, can I write AC square? No. AC square plus BC square minus 2 into BC into, I am finding DC value. DC value, I am taking this angle, that's, you want adjacent side, that's why I am applying COSINE. Adjacent side, DC by hypotenuse, that is AC. AC length is, this is small a, small b, small c. AC is small c, that is DC is equal to AC length is small b into COSINE. The DC value is substituted here. DC is AC into COSINE. Now AB square, that is AB length is C square is equal to AC length is B square plus BC length is small a square minus 2 into BC is small a, AC is small b into COSINE. This is the cosine rule. This I am writing as C square is equal to A square plus B square minus 2AB into COSINE. This is known as cosine rule. Law of cosine. Law of cosine. From this one I am finding COSINE value. COSINE is equal to A square plus B square minus C square by 2AB. That is A square plus B square minus C square by 2AB. 2AB. This cosine. Similarly for cosine. Cosine means B square plus C square minus A square by 2BC. Cos B, C square plus A square minus B square by 2AC. Cos A. If you want ratios also, cos A is to cos B is to cos A means this one is to this one ratio. Now, by using this one, I am explaining one problem. Now, see now, this value in terms of you want K, but K is perimeter of triangle ABC. Now, see now here, B cos square I am writing as 1 plus cos C by 2. One formula is the cos square C by 2 can write 1 plus cos C by 2 plus C into 1 plus cos B by 2. Cos B by 2. Now, see on here. B1 B by 2 plus C by 2. B by 2 plus 1 by 2 of B into cos C plus C by 2 plus 1 by 2 into C into cos B. Now B by 2 plus C by 2, half we can take common, that is B cos C plus C cos B. By using projection rule, what is the value of this one? Small a. Half we can take each other down. This value A plus B plus C. This is the perimeter, but perimeter must be K. K by 2 is the answer. K by 2. This is the projection rule. Small a is equal to B cos C plus C cos B. This is projection rule. I am explaining one more problem on the same concept only. Projection rule. Now, projection. In a triangle ABC also. In a triangle ABC, ABC, AD is perpendicular BC. AD is perpendicular BC. Now, this one, AD perpendicular BC, 90 degrees. This is small a length, small b, small c. Now, can write small a is equal to BC. BC can be written as BD plus DC. BD plus DC. How to find BD value? BD one. I am taking this angle. That's why it is adjacent side. Cos B is equal to adjacent side. BD by hypotenuse, that is C. BD is equal to C into cos B. Similarly, you want DC also. That's applying cos C. Cos C is equal to adjacent side DC by B. That is DC is equal to B into cos C. Applying the BD and DC are shifted here. Now BD value is C into cos B. Small c this one. DC value B into cos C. This is the projection. This is small a. If it is given two sides and the two angles is given, the corresponding angles. If you want third side events, apply this formula. Next, similarly, small b is equal to a into cos C plus c into cos C. Small c is equal to a into cos B plus b into cos A. Projection rule. These three formulas are projection rule formulas. And one more. On this concept, I am explaining one problem. No, this problem belongs to projection rule. No, in triangle ABC, small c into cos square by 2 plus small a into cos square c by 2 is equal to 3b by 2. Then ABCR belongs to small c into cos square by 2 plus small a into cos square c by 2 is equal to 3b by 2. Then ABCR belongs to either AP or GB or HP is asking. Now, I am taking given condition. Small c into again cos square a by 2. I am writing as 1 plus cos a whole divided by 2 plus small a into cos square c by 2 1 plus cos c by 2 is equal to 3b by 2. Eliminating on both sides by 2. Then remaining is c plus c cos a plus a cos c is equal to 3b. Eliminate 2 on both sides. Denominator values. A plus c plus a into cos c plus c into cos a is equal to 3b. You know everyone, by using projection rule, a cos c plus c cos a value small b. A plus c small b is equal to 3b. Same this side. A plus c is equal to 3b minus b is 2b. A, B, C are sum of extremes is equal to twice the middle one. Then A, B, C belongs to AP. That implies A comma B comma C belongs to AP. Sometimes asking in J type A plus C by B is equal to dash. That answer is 2. Into J type question form means. Next, I am explaining one more problem. Now, once listen to it. In triangle ABC, AD is the altitude from A, B greater than C, and it is when angle C is equal to 23 degrees, and AD is when ABC by B square minus C square. Then find the angle B. It is previous mains problem. Related to it is belongs to sine rule. Now it is given in a triangle ABC. In a triangle ABC, ABC, AD is the altitude. It is perpendicular to BC. That is 90 degrees. Now Now find, it is given AD, that's why finding sin C. In this triangle I am taking ADC. Sin C is equal to AD by, this length is small a, this length is small b. C. From this one is AD is equal to small c into sin C. AD is equal to small c into sin C. Small c into sin C, sin B now. AD sin C is equal to opposite AD by B. This is B. No. But AD was given ABC by B square minus C square is equal to B into sin C. Eliminating B on both sides. Remaining sin this side C by sin C is equal to B square minus C square, B square minus C square by C already is there now, this is goes to A. By using sine rule, A by sin A is equal to C by sin C or not. In place of this one written as A by sin A is equal to B square minus C square by A square. A, sorry. By cross multiplication, A square by B square minus C square is equal to sin A. Now, in place of A square I am writing as, I am writing here, no problem. Now, A small a is equal to 2r sin A. 2r is 4r square sin square A by 4r square, you can take come from these two. Sin square B minus sin square C. 4r square cancel equal to sin A. One sin A get cancelled. Now again, one more sin A is there here. Sin square B minus sin square C can be written as sin of B plus C into sin of B minus C. Sin of B plus C into sin of B minus C is equal to 1. Is equal to 1. Now, A plus B plus C equal to 180, but B plus C equal to 180 minus A. Sin of 180 minus A is sin A only. In second quadrant, sin positive only. Sin A by sin A into sin of B minus A is equal to 1. Eliminating sin A. Numerator and denominator also. By cross multiplication, sin of B minus C is equal to 1. 1 can be written as sin 90 degrees. Eliminating sin on both sides. That is B minus C is equal to 90 degrees. Already angle C is given. How much is angle C? 23 degrees is given. So angle B is equal to 90 plus C. 90 degrees, that is 23 degrees. That is 113 degrees. Previous mains problem. Mains problem. Angle B is equal to 90 plus 23 degrees. This is most important problem also. Thank you very much. Continuation tomorrow, everyone.